Hi, this is John Isles and welcome to Geometer's Paradise. Today we're going to be talking about Unit 6, Lesson 3, Congruence and Polygons. We're looking for three objectives. The first, to define what it means for polygons to be congruent. The second, to be able to identify congruent polygons. And third, to be able to solve problems that involve congruent polygons. So, our first deal, we want to talk about what is a polygon. First of all, a polygon has two components. It has vertices and sides. That was the wrong button. Here we go. It has vertices and sides. A vertex is the point where two sides meet. That is the wrong color. All right. It's the point where two sides meet. A side is the line segment that connects vertices. So this side connects these two vertices. Each side connects two and only two, or exactly two sides. So each vertex connects exactly two sides. The sides are not allowed to overlap, meaning that we can't draw a polygon that looks like this. Okay, this shape itself is not a polygon. There is a polygon inside the shape, but this line right here disqualifies the whole picture as being just a polygon. Other things that aren't polygons are anything with a curve. That's not a polygon. Anything where you have multiple intersection like this. This is overlapping, what I said when two segments overlap each other. This vertex connects four different line segments. So this is actually two polygons, one triangle on the left and one triangle on the right. You also have to be closed, so you can't draw something like this and call it a polygon. This is not a polygon. All right, so when we talked about congruence in line segments, we defined line segments as being congruent when they have the same measure. So they have the same length. Okay, and we can mark this in a picture with a single hash mark like this. Or depending on how many congruences you've already marked out, you could have two hash marks or three or four. It doesn't really matter, but they have the same length. Angles are congruent when they have the same measure. Like, for example, if one is 30 degrees and the other is 30 degrees, we call that congruent. We mark angles congruent by drawing little arcs inside the angles, so these would both be angle congruent 1. Sometimes people mark them like this. All right, so there you would have a mark 2. And some people choose instead to mark them with two. This is the more typical, I think. 2 marks here, so this would be an angles of mark 2. If you end up with something like this, where one is marked and the other is not, that doesn't mean they're not congruent. It just means that we don't know they're congruent. We might have to prove that they're congruent. All right, so what does congruence mean for polygons? Looks like we lost the bottom of that one. That's too bad. So for polygons, we want to identify congruent sides. Like, for example, this side is congruent to this one. And if I can do that for all the sides, that's something. Okay, but it's actually not enough. Okay, we need more than this. This is not enough information to have these two polygons be congruent. What we can do, or what we need to do then instead, is we also need to know that the angles are congruent. Sorry, my cell phone just buzzed there and it caused me to slip a step. If I can tell that all the angles are congruent, all sets of angles and all sets of sides together, all right, then these two polygons are said to be congruent. We say that corresponding sides are equal or congruent, and we say that corresponding angles, I need to write that word, corresponding angles. Now, corresponding means same position. So it's easy here to say, hey, this is the top and this is the top. But what happens is people will run clockwise around a shape. So they might start off and say, hey, I know that this angle is congruent to, say, this angle. But then they'll stop paying attention and they'll match this angle to this one. Notice that this shape has been flipped. This is a flip, okay? So that means this angle doesn't match up to this angle. That's bad, okay? If we call this the angle 2. If you come over here and you match this one to angle 2, that's bad. Corresponding means same relative position. You have to consider how the polygon has been drawn. The angle 2 here, which goes from left to right, actually goes right to left over here. The second angle is this one. So this is the angle marked 3, while this is the angle marked 2. So pay attention to what's going on with your shapes. The other thing about quadrilaterals especially is that you have to look out for the fact that you can draw a quadrilateral and the order of the sides can be messed up. For example, let's see if I can do this here. I'm not sure if I can. I'm going to trace a side here. Let's see if I can move that side. Can I pick that up and move it? Oh boy, that's bad. Okay. Well, I messed everything up. Ha ha ha. Let's step back. Okay, let's do this. I'm going to step out of my slideshow here for a second. I am ready to do that. Go back to this slide. All right, here's what I want to do. I want to show you something that's pretty interesting. Let's trace a side here. So there's a side. Okay, so this is the long horizontal side. Now I'm going to trace this vertical side here. All right, and I'm going to connect it. Then I'm going to trace the short side. And then I'm going to trace the bottom. Look what's happened. I've created a new polygon. The angle measures are different, but the side measures are the same. All the same side measures. Boom, just like this. So this polygon is broken. All right, this is not a congruent shape to these others because the angle measures are not congruent to one another. And just because you have congruent sides doesn't mean that you are congruent. You have to have congruent angles as well. That's what I was trying to get at there earlier. Now, suppose that we have two congruent shapes after all. All right, and let's see. There we go. Here we have polygon bare, and notice that I have the angle measures in here. Here's 45, 75, 150, 90. 45, 75, 150, 90. Okay, and then the side measures. All right, we say that parts are correspondingly congruent when they have the same measure. So all I have to do is look at these sides and write them down, and that's writing down correspondingly congruent. So for example, BE has length 13, so it is congruent to LI, because LI has length 13. EA is congruent to IO, because both have length 5. AR is congruent to ON, because they both have length 7. And BR is congruent to LN, because they both have length 10. Likewise, angle B and angle L are both equal to 45 degrees. Angle E is congruent to angle I, because they're both 75. Angle A is congruent to angle O, because they are both 150. And angle R is congruent to angle N, because they're both right angles. We have 8 pieces of correspondingly congruent information. And this is basically double the number of sides of the polygon. You got 4 sides, you're going to have 8 congruence statements. You got 5 sides, you're going to have 10. One set for each side and each angle. Now, once we know that the shapes are congruent, or once we have congruent statements for all these sides, we can name the shapes. We can write what's called a congruent statement. The way a congruent statement works is you start by naming one of the two shapes. For example, bare. All right, I can call this one B, E, Oh boy, hang on one second. Pen just did its thing on me there. How about B? Okay, sorry. BEAR. All right, so polygon bear is congruent to. Now we don't just name it. We might want to name it lion, and in fact that's what it's going to be. But you don't just name it lion. You have to look at B. What is B congruent to? L. So L is the first letter. E is congruent to I, so I is the second letter. A is congruent to O, so O is the third letter. And R is congruent to N, so N is the last letter. Okay? You don't just name the second one. You can do any name for the first. All right? Specific name for the second. All right? You have to match to get the second one. Now, there is some rules for how to name it. You have to pretend you're a train. You have to stay on the track. BEAR or RBEA or AEBR or ARBE. You have to stay on the track. You can't do this. REBA, no matter how much you like country music. All right? REBA violates the rules because you cross through the polygon not once, but twice. Okay? So be careful. You must follow the track when you name the polygon. Okay. For this particular slide, we shouldn't call this CPCTC. It's really CPCPC, but for the sake of clarity in just another day, we're going to call it CPCTC. Corresponding parts of congruent polygons are congruent. Later, this is going to be corresponding parts of congruent triangles are congruent. What it means is that if I have a congruence statement like this one, I can use it to write congruence statements about two polygons that I know nothing else about. If I know that bear is congruent to lion, then what that means is that angle B is congruent to angle L. So I can write that. Angle B is congruent to angle L. Angle E is congruent to angle I. Angle A is congruent to angle O. And angle R is congruent to angle N. And so we have derived our angle statements all by CPCPC. Corresponding parts of congruent polygons are congruent. That last one looks like an E. Let's see if I can fix that. All right. We can also do segments. All right. We can go up here now. This is a little more involved. What we're going to do, we'll take the first two letters as BE and the first two letters as LI. BE and LI are congruent. BE is congruent to LI. Then EA is congruent to IO. And AR is congruent to ON. All right, finally, first to last, BR is congruent to LN. There's always the same number of congruent statements as there are sides. Same number of congruent statements as there are angles. So the last one involves connecting the last to the first. So it's B to E, E to A to R, and then R back to B again. All right, you got to complete the circuit. Okay? This is also by CPCPC. Corresponding parts of congruent polygons are congruent. All right, so when you have a statement like this one, bear is congruent to lion, and you have givens over here, what we can do is set up equalities. See, BE is 3x plus 8. So I come over here and I find BE. BE is congruent to LI. So BE is congruent to LI by CPCPC. Well, BE is 3x plus 8. And LI is 10x minus 6. See how convenient that was? Even though my pen stopped working? This is by substitution. All right, and then of course we can solve. Add 6 to both sides, we get 14 over here. Subtract 3x from both sides, we get 7 over here. So x is equal to 2. Likewise, I know that angle B is congruent to angle L. So 3y is equal to 45. Incidentally, this is CPCPC again. All right, and then we divide both sides by 3, we get 15. Easy enough. All right, this is the final slide. It's in here because we need to talk about regular polygons real quick. First of all regular polygons have given angle measurements that are congruent. So all the squares have 90-degree angles, they're all congruent. All regular pentagons are congruent. I don't remember their angle measure off the top of my head, but they are all congruent. But what happens is these are not all, let me back up. All the angles of squares are congruent to one another, but not all squares are congruent, okay? And all regular polygons are congruent, have congruent angles, but they're not all congruent. For example, these two are congruent to one another, but these two are not, okay? The angles are all the same in both pictures, but the side lengths are not. So the large one and the small one, these are not congruent, but these are. In order for two regular polygons to be congruent, you must also know that the sides are the same. Okay, and so that's just kind of the last bit of information. All right, so good luck, and we'll see you in class tomorrow.